So I started with having you talk about graphing integers because that can be a strategy you use when it's time to just order integers. And one way we order integers is literally lining them up in order from least to greatest. So let's imagine I have some temperatures from least to greatest. 38 degrees, -5 degrees, 27 degrees, 84 degrees. So when thinking about least to greatest, some of you might be able to go, oh, I know right now, the coldest temperature there is -5 degrees. Whoops, sorry, I said it wrong. The next warmest temperature is 27 degrees. After that would be 38 degrees. And the warmest one of all would be 84 degrees. If that's not something that you can just do yet, we also can put them on a number line. Think about, in this case, we might want to put 0 closer because we need one. Let's say this is -5. And maybe I'm going to count by 5. So 5, 10, 15, 20, 25, 30, 35. If you're wondering, Miss Funk, where did you come up with going by 5s? There's no one right way to do it. I was just thinking of a scale that seemed like it would make sense and would fit all of the numbers that I need to get in here. And even with that, it's going to be close. All right, so I have my -5. 27 is going to be, if I add some tick marks in here, 27 is going to be right there. 38 is going to be right there. And 84 is going to be right there. Notice that in order from left to right, once they were on the number line, was -5, 27, 38, 84. Now, the other way we sometimes get asked to order these is to use the symbols. And this is where you've heard of like the alligator mouths or whatever. So we have, this is greater than. This is less than. And this one you're pretty familiar with is the same as. Equal to is what we often say, but equal just means the same as. So if we have a couple of integers, let's say we have to compare 3 compared to -5. When I want to figure out which symbol, well, first of all, I know they're not the same as. Having $3 is not the same as owing someone $5. So they're not the same as. But now I have to decide between greater than or less than. And this can be tricky. So it can help to think in our mind of a number line, even if we don't draw it out every time, and say, all right, 1, 2, 3, 4, 5, -5, 1, 2, +3. The greater number is always the number that's the furthest to the right. Okay, so in this case, 3 is the greater number. It's more than -5. So now I need to show the symbol that's greater than, and that is this one. We often hear these. There's a couple of strategies that kids often use to remember this. One is to think of these as alligator mouths. Okay, that the alligator always wants to eat the bigger number, right? So in this case, the alligator wants to eat 3 because 3 is bigger than -5. The other strategy I've heard is people think of the less than sign as like if somebody sat on an L, they would squish it, and so it looks like an L. So when we use this, we're saying that this number is less than squished L, the other number. What would be another one? If I had to compare, this can be hard when you have to compare two negative numbers. So negative 14 compared to negative 25. So again, if we think in our heads of our number line, if this is 0, all right, so if this was negative 25, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's negative 14. Negative 14 is further to the right than negative 25. So this is the greater number. I should have done these in the other order so you could have seen the other sign. And you might think, well, how does that work? Because 25 is a bigger number. So this is like owing more money. So if you have to be, if you are one of these things, would you rather owe somebody $25 or $14? You'd rather owe them $14 because that's less money that you're in the hole. You're closer to $0. Or if we think about greater as in elevation, if somebody is 25 feet below sea level or 14 feet below sea level, this person is up higher. They're not up to sea level, but they're up higher than this person. So again, the sign would go the same way. Negative 14 is greater than negative 25.